All right, that was the prompt, and I guess you guys have an idea now what happens with all the different features we have within the prompt playground. I already showed you the model piece and the fine-tuning part, so I'm not going to go through that again unless you guys had any questions. But I want to go to the agents now and talk about the entire email automation agents we ended up creating. If you remember, just to remind you, I know it's Friday, so what we did, as I said, is we take the entire process and we built that within GALE. Now I'll show you the GALE flow because there is a lot of different pieces here. Don't get shocked by the complexity of it. It's not actually complex. It's just multiple different nodes stitched together. So when you go into the agents, first of all, I mean, obviously you can create a brand new agent right here. We have the entire architecture of workspaces behind the scenes, means everybody who's logged in have their own spaces. Your agents are your own unless you share them. We will have mutual collaboration enabled within agents pretty soon. But right now you have the ability for you to share, and the permissions and the administrations around that are already in place. So what you see here, all my agents, well, I have not built anything. Everything is built by my team, so I have nothing. And all the agents are shared, and I'm going to walk through each one of them, what they are. So let's go through email automation piece. Once you go within the agent, you will have a development version, and you'll also have a deployed version if you have deployed the agent. Dev version, there's always be a dev version because once you, before you deploy, there is going to be one. After you deploy, you can continue edit that and create new versions of it. And within the dev versions, you can have version control by that itself. Sharing permissions, again, no rocket science here. You can share it to different people. They'll have access to it. Once you have the agent deployed, you will get an URL for you to access the agent from, and you'll get a full description of how to access that. And every agent has an input and an output. You define what the input output is, and based on that, that becomes the contract for the API, and we automatically create using that piece of information what the API contract should be. The way to access GALE agents are through API keys, and you generate the API keys right here. And once you generate them, you can use them, share it with anybody. I mean, this is the same thing, where like any other models. You have the ability to add guardrails. Now, once you configure a guardrail within the platform, you have to configure the guardrail across. Essentially, once you configure the guardrails, every individual users have access to it, and they can bring that to that specific agent. You can go and say, well, we have added a few guardrails, but let's say anonymize. Let me quickly actually show you before that. We are building multiple different integrations. Currently, weights and biases, AWS, Hugging Face are already there. We're working on integrations that's already in the platform to bring it over here. This is where you come and configure the guardrails. We support few right now out of the box, and this is one-click deployment. So once you figure out which guardrail you want to use, when you hit deploy, that gets deployed, and now that's available for you to consume in any agent you want to. We will soon let you define your own guardrails. We'll give you a simple SDK based on which you can define the guardrails, and once you have that, you can deploy that within the agents as well. So I've deployed a couple of guardrails, and I'll show you once you go into the agents. Now, once you enable a guardrail within an agent, you can experiment with that. Because you want to know what is the guardrail doing what's supposed to do. I have the anonymization agent. Let's say, for example, I'm taking this piece of information. So there is a lot of personally identified information here. There is name, there's date of birth, etc. So I want to apply this agent, this guardrail, and see what happens. So you can test that, and then it'll predict what's happening. So essentially, it says there is a risk score of 1 because that means there is a significant amount of PII information. And it automatically takes those PII information out, and it redacts that. So when you're sending this information to the model will see this, and it will never see this. So the model will get the information that's related for it to respond back, but the information that needs to be private from an organization perspective will never go into the model. You can obviously configure this and say what kind of information I want to take out. Right? You can say I want to take out the credit card information, I want to take out the email address, I want to take out SSNs. You can define what kind of information you want to, and then there is a threshold. Once you define a threshold, what that defines is when the agent is running, and if there is a guardrail that's applied, if it's below a certain threshold, then the agent will fail. It'll come back with a response saying, something that you are not supposed to do has happened, and go ahead and do whatever you need to do. Or you can build an alternative path there and say how you want the agent to fail, and based on that, do you want to take a separate path, or you want to execute a separately new agent? So all of that is a possibility that you can do. There's a lot of other small parameters here. We will enable that with documentation. You'll be able to understand it, so you can enable that. Now, I'm not going to enable the anonymization agent because that may, yeah. Where do I, sorry. So it is part of the model. So for every model, we have what it can do, and we will enable that. And if you want to, as I said, have your own specific model that does something different, we will provide a way for you to build something. But this is configurable because once I add, so for example, let's go toxicity. And let's put all of them just for the fun sake. Now regex, actually, you can define a regex. Every time it finds something there in any kind of prompt, that before it goes to the model, it look at this regex and say, well, that happened. Now you got to figure out what you need to do with it. Toxicity is you have to define what kind of, essentially it is already inbuilt in terms of what kind of toxic information it is looking for. And then you can say what is the threshold, and if that threshold meets, do you want to actually end the flow or continue with the flow? This is for anonymization. We will actually have a list. If you randomly say something new that's not in the model, it will not use it. Right now, what we're doing is, now thinking about it, I think we probably have to change the interface. Instead of giving like tags, we should probably enable you like a drop down that you can select, because that's a predefined list, but we'll take a look at that. But let me remove all of this. Okay, this is where the rubber meets the road. Okay, so the entire email automation that we talked about is built in here. So what's happening is, first of all, this is where you have the input-output definition. As I said, you define the input-output for the flow, and this becomes your API contract for it to generate the APIs. So all you're doing here is what kind of parameters that I want to make sure is part of the input, and what parameters I want to make sure is part of the output. So here I'm saying email content is an input, and sender email. So once this entire thing is processed, it is sending an email out to somebody. Now this is an input. So when you're doing the email automation, you are sending the email. You know the person who actually sent an email, which customer the email is coming from, and then that email address is extracted out and sent as an input as well. So once it finishes this flow, it extracts the template of the email that has to send back and sends it to that particular individual. Output, what are the different pieces that needs to be extracted out, and all of this is generated as JSON, and then you can process the JSON as you think is appropriate. These are the different variables that we want to extract as output, and once you define these, then you can start embedding them in different parts of the flow and saying, I'm going to load this particular variable with what kind of data. Now, there are various different type of nodes. The AI node, API node, I don't have to go through it. The only difference is, if you guys have been using the platform, with function node, we support Python alongside JavaScript. So that is enabled right now by default. There is obviously a limited amount of libraries we support out of the box, because there is a security constraint. We can't enable all libraries to happen, especially if it's running on the cloud. But one of the things we are experimenting with is to see if you can actually sandbox this completely, so that you have complete access to all potential Python library, and the execution happens outside of our cloud. That's still work in progress, but right now we are, the traditional libraries that you'd want to do typical functions within Python is available. Conditional logic node, no brainer. So once you have all of these nodes, this is a navigator, you can look at all of these nodes. Currently we are grouping them by node. What we are also building is grouping by the order with which you actually create it, so you can actually navigate, especially when it becomes complex flows like this. Instead of you moving around, you can click on this and navigate to that specific node. Grouping of node makes sense, but also grouping of the nodes based on the order makes even more sense, and we are working on that. And now I don't know where I am. That's the reason why you need the order of this. So what's happening here is we are extracting, the email is coming in. We are doing some cleaning of the email so that we actually can extract out the piece of information that only matters. It's a simple function node that writes a very specific function, extracts out all of these pieces of information, and then this information is pushed onto a variable. So across the flow, there is a context variable, and you have a bunch of context variables that are global. Whenever a node gets executed, it takes an input and it gives an output. All of that information is stored in some variable that you can easily access to in any other nodes. So in this example, you can see that in the context, we are actually putting cleansed email content as your variable. That's the variable that's going to be available across. You have the ability for you to test these functions right here and see what's happening with the log. I'm not going to go through them. I'm going to go through just a couple of nodes to show you what those are without going through all of them in detail. AI node. So remember when I talked about in the prompt playground, you have the ability for you to copy it as an AI node. When you do that copy as an AI node there, you can come here and say paste. Once you paste that, this entire node gets pasted along with your prompt, along with the model you have chosen, the parameters you have experimented with that made sense for you, and all of that is pasted so you don't have to retype it. It's just an easy way for you to get this node up and running without having to drop that and restart it. Then once you have this, this is the AI node I talked about. This is a logic node, very traditional in terms of how you define the if-else logic, how I would want to, no surprises there. Then I want to show you an API node. I don't know if we have one in this particular, oh, there you go. So here, when you have the API node, you can get the API, you can define and test those APIs. Now this will, if I run this, it'll fail because it's actually dependent on a variable inside the flow. So it's expecting that variable to come in. I have to run the flow for it to execute. But if you have a general API and you know what information you want to give, and if you want to give test data for you to experiment with it, you can do that. I'll show you another example how the API node works. So that is the process we go through building all of these. Now, once it's done, you can play the flow right there in the playground. And because it's expecting a certain type of information, oh, come on. Okay. Oh. Sometimes my mouse gets switched on. It's not. Come on.
What's happening today,
Well, my laptop crashed or my browser crashed. There you go. So now we're just, obviously, when you run this in production, you will send the emails directly to the API. As a matter of test, you get everything you have defined as an input variable. This is a simple playground for you to give an example into the input variables and see what happens. I will send an email to myself, and if I get lucky, you will see a response at the end of it. So what you're seeing here is the execution of every node. And there are a lot of things happening, and you'll have a lot data for every execution. And so, for example, it started with the email processing. It tells you, is that big enough? Yeah. What happened? What was the total time taken? Again, from the function node, that's not important. But when you go into an AI node, we actually show you everything that's gone into it because the prompt is constructed in real time. So you can actually go and say, well, what prompt was actually sent into the model? And alongside, what was the raw request that went in the model? What are the different parameters that went in? You can go and look at that to make sure actually the model got what it needed to. Then you will also be able to see the parameters what were the parameters that was set for that particular execution in that particular node, so you know exactly what happened, and you will be able to trace each one of this. You see the raw response out, what came out in terms of this particular node, because here we are talking about identifying the category. So it has identified the category as account closure. 645 tokens was taken, completion tokens was 649. The inference time was 0.12 seconds, and what the node was and what the uptime was. And finally, you can see what the output is. So this is useful when you want to debug exactly what's happening when you're starting to construct an experiment with this. Every step of the way, so for example, if you had a API node execution, you will see exactly what was executed and what kind of response you ended up generating. And when you do all of this, you can go back and look at your entire context variable of what happened across the execution, where what kind of variable existed at each step of the way. So you'll be able to see what went in, what came out at each of the nodes. This is an easier way to look at it. And if you're a techie and if you want to go into the details of the JSON, you have the full details of the JSON here available. Now, once that's done, eventually you end up getting the output. And the output here, we got this as neutral sentiment, the email that was given, the entities were identified, the case type, there was a, depending on the case type, we do different executions in the flow. It identified the case type to be a complaint, account closure, and there was, that was the email template that was extracted out from what's already there in a bunch of email templates available in AWS, which we've integrated with, and then the email was sent. If I'm lucky, I'll see the email. I wanted to make sure that I've not something open there that you shouldn't be seeing. Okay, so I did get an email. That's a templated email. Obviously, it's pulled out. So all of this happened quickly. Obviously, you saw that. But if you imagine running this 6,000 times a day, then there's a significant amount of productivity gain that you get out of it. 10 minutes per email, 6,000 emails, you're looking at 1,000 hours a day. That's a substantial amount of reduction. And there is also less amount of risk here because you are using a templated email, and that's the strategy they use for obvious reasons. It's a bank. So there you go. That's use case number one. Any questions?
Email listener part of it. I mean, I know the agent configuration makes sense, but how is it listening to the inbox when an email comes?
So right now, the way we have actually done this is we built the flow in GALE. There is some, because they already have all of this, when the emails come in, they process that emails, et cetera, behind the scenes. When they are ready, they trigger the API, send the email to us, right? So there is I think I was explaining this day before yesterday when I was talking about it. One of the design principles of GALE was that we wanted to make sure that this coexists with everything you have within the enterprise. We know a lot of these are already happening, and that's one of the reasons why I said we will not have an UI specifically. You can, either you can say, okay, I will send an email to you, or you can say, no, I will not send an email to you. I'll make this some kind of a cron job. I will put a node which will actually talk to the Microsoft email server, extracts that out every time I get a trigger, and runs this. So you decide how you want to execute this within your organization, and that depends on the workflows that you currently have.
So this flow can be exposed as an API?
It is right now. I mean, that's exactly what's happening right now. This flow is exposed as an API. And if I go to the Postman and I execute this particular API endpoint, then I provide that as an input. In fact, if I execute exactly this along with an API key, let me see. Okay, this is real time, not Postgres. Let's see what happens. Well, Postman is slower than our product. I think we are losing out the speed on API. So it's all API, so you can pretty much trigger anywhere from you want to. And that's the response we actually saw in the playground as well. Are there questions about it? Yeah. Okay, so let me show you one that we're working on. So this is an experiment that we want to actually do. So what's happening here is there is a bot conversation that comes in. We have hard-coded this bot conversation. We're not exposing that anywhere. Once that is done, there is a summary of that that's getting generated. Now, after the summary is getting generated, there is another model that's evaluating the summary based on certain parameters we've actually defined. Then once that definition is done, it evaluates it. Then the first model goes back, learns from that, and regenerates the output. So I'm going to show you that. So this is the bot agent conversation that we're doing. The moment you start using commercial models versus our models, you can see the difference in terms of the latency and speed. Okay, so let's start looking at what's happening here. So first, it generated a summary. That's a conversation. There is a summary that was generated. Now, this is the model that's evaluating. It's a good score. It's at 4.5, and it's explaining the relevance is 5. The summary includes blah, blah, blah. Then consistency is good, coherence is good. It's explained what it's supposed to do. All of this piece of information is actually now evaluated by this model. Now, this model has taken that input and updated this summary once again to make sure the small pieces that it was not right about, it's actually enhanced it. So now, I mean, if you think about a combination of your custom models and commercial models, now this becomes quite powerful, and your entire chain of thought can happen right here. I was not planning to show that. But okay. You're stealing my thunder, man. Let's talk about that. Okay. So this flow is, this is internal. And what we're doing with this is, when we have a new prospect that we're working with, we have a series of steps in terms of trying to go to this prospect and figure out how can we actually become a partner with them and provide our products to them. So for us to do that, our business development teams go do a research on that organization, and they create a comprehensive report of what that organization does, what are the key value propositions they have, what challenges they have, who are the key decision makers within that particular organization. For each of the decision makers, what is that they do, what are their experiences, and which of our products actually make sense so that we can enhance the value of that organization. So there is a bit of research that goes into it. Now that research, I'm thinking if I should show it to you or not, but it's a comprehensive PDF document, okay? Hold on one second, I'll show you something. There's no secret sauce, but I may be legally liable. Okay. So you can see that there's several page documents of research that goes into this, right? And without going into the details of it. Now, post that, as I said, we also look into who the individuals are. And that's important because obviously we want to make sure there's a tailored message to each of these individuals, not a general emails we all end up getting. And this process happens manually today. It still happens. We are updating this flow. So what we have done here is this report now goes into Search AI. So it's indexed, it's obviously chunked, and there is all of this piece of information available there. Alongside this, we have all our product information in Search AI. Alongside that, we have each of these individual profiles from LinkedIn in Search AI. Now, when you go into the flow and say, okay, what we are trying to do is we're going to tell you which company, we're going to tell the model, the entire flow, which company, who's the person we want to actually go and talk to, and what product do we want to actually try and position with this particular individual. When we do that, in our process flow, obviously, we send an email, we go to LinkedIn, send an email, and there is also, obviously, we call customers saying, you know what, this is the opportunity. We think there is a synergy between you and I, your company, and what our product is, blah, blah. So what this flow does is it generates a guidebook for the call, saying these are the things you want to talk to about this particular individual based on their experience. These are the points you want to think about, and here are the step 1, step 2, step 3. It generates the first email. It also generates the first LinkedIn content. And if you're lucky, we'll see it. So we got something there. So the first piece it's doing is it's going in, it knows the customer, knows the individual we're trying to, so it's extracting out all the information we've already indexed within Search AI, extracting that piece of information. Now, we're not getting the answers, we are getting the chunks. Now then, we are processing, basically saying that this is what we want you to generate in terms of the call guidebook, generate in terms of email, and generate in terms of the LinkedIn message. So once that gets executed, obviously it's doing a lot of different back and forth. You will see something like this. This is the guidebook for the sales call. Essentially, it tells you, this is what you want to do, part 1. How do you understand what you want to talk about the customers? This is what you want to do in part 2, part 3, and explains how we want to close the call. That's number 1. Then it generates an email. I mean, obviously, we do want the business development executives to take a look at this and not directly send this out. That's not what we're trying to do. But they will have the first cut in terms of getting all this piece of information, and that email comes out, and actually now it's taking the particular individual's experience, taking the organization's need, taking our product, combining all of the pieces together, and figuring out how do we actually position this. And then there's a LinkedIn email as well that's generated. And there's a series of another 10 steps we need to do, but you get the idea. And this is where the Search AI and GALE comes together. And there are a lot of use cases within enterprises. We know that these two will live together, and that's why we are trying to work on deep integration with Search AI, along with the idea that he just gave us. Yeah.
Is it like a predefined library of functions?
Huh?
Is it like there is a predefined function, a library of predefined functions that we can use? Or?
Well, I mean, essentially, that's the predefined library of prompts that we, that will be useful. When you say functions, for what kind?
Yes. For example, you have like a function.
Oh, these functions are not, they are not special. Basically, what they're doing is they're extracting one piece of information and moving it somewhere. These functions are not special. I think the special ones are the Search AI thing that's extracting out the information. The special ones are Gen AI nodes, which are actually creating the content.
And what sort of content types basically you have to
So far, we support text, but we will start supporting multimodality. In fact, we also support audio to a certain degree. Image is yet an experimentation. We're working on it. In fact, I will show you one more example where we actually take an audio transcription, not audio call recording, and go through the entire process of transcribing, summarizing, and translating it to different languages as a part of the flow. Yeah.
These kinds of flows as like recipes that you do.
Yes, we are working on that. I think there is a lot of common use cases that we see across the organization. Along the prompt library, we'll also create a flow library that you can just choose and directly start from base and then improve on it. Yeah. Sorry.
You can do it. So let's say I'm extending what you're saying right now. So I'm going into that having less requirement for the API and trying to match the scenario with the document or the set of flows. So taking a banking example, let's say there's a full closure of a loan, and the example which you took that they didn't want to do it.
Yes.
and put it forth without having to do the programming of if else using the API analysis.
Right. I mean, that's where I think Search AI and GALE comes together.
Yeah.
When you have the rules defined in Search AI, we can definitely make sure that rules are adhered to. And it also depends on the use case and how strongly are we adhering to the use to that particular bunch of rules. There will be obviously breaking of logic. If you get this rule, do this. If you don't get this rule, do this. But certainly, you don't have to kind of build all of them in there if there are a set of rules clearly defined. Because at the end of the day, it's just text. We have to understand what the text is, where you're getting the data from. If it's interacting from various different systems and you're extracting that to evaluate that rule, then it's not just extracting from Search AI. You may have to build that within GALE. But if it's just a piece of content that we want to use as a reference, and then we can certainly do it.
Quick question. And the purple and blue are articles that you are making directly to search assist to gather just the chunks.
Correct.
And not using generative
No.
in that pass.
No.
Just the chunks,
Just
and
chunk.
then you pass to the
That's right.
final one to
Yeah.
process all the data.
Correct. If you see here, these are the chunks that's come out.
Yes, that's nice. And quick question. If I want to add, for example, besides the chunks and everything that we have already in Search AI, maybe a PDF with the image and everything, we can incorporate in that path maybe a commercial to read the document and extract additional
That's right.
information, and then finally with a function
Correct. And because in this particular scenario, we want the entire control of which chunk to use within the flow, and we didn't want the Search AI to decide that for us. Yeah.
Okay, one last question. I may have missed the previous session. So say you have like certain jobs and say classification. Is that the search assist what you develop that?
When you say certain jobs, what do you mean?
So say for example, like say debt recognition and classification of those units. Are those built
In here, yeah. No, it's in here. So we have models trained for it in certain scenarios. In certain scenarios, we use off-the-shelf models as is. Okay, so time check. I think we are about 5 minutes away. Do you guys have any questions, or do you want to see another flow? Okay, I can show you two interesting flows, and this one is a risky one, but we'll try. Huh? Yeah, that's the one. So this one is a flow that actually takes in an audio file as an input. And if it's English, it does the English. If it's Spanish, it actually transcribes it, summarizes it, translates that back into English, identifies the sentiment and a few other parameters, and then sends it out. Right? So let me show you.
Hi, thank you so much for calling WAM. My name is Allie. How can I help you today?
Hey, just trying to change the payment info on the website since my sub is about to renew. I was wondering if you could do it on the phone.
Yeah, that shouldn't be a problem. Could I have...
I don't want you to listen to 1.5 minutes of that, but essentially that's the input. So I'll run this flow without going details of it. So
the input is like a voice.
it's a audio file, yeah. It's a call recording. So all of these files are ideally you would send that file, but what will happen is you'll upload the file to S3 bucket or somewhere, send the link, and that's what we process. Right now it's already uploaded to S3 bucket. Say, well, what language is this in? And then what it's doing is first it's transcribing the full call, 1.5 minutes of the call, and then it's going through the process of identifying what's happened within the call, summarizing it, and then also identifying the intent for that, and you will see all of that piece of information coming in.
It's like quality control.
Huh?
It's a quality control.
Yeah. So here, so first it is identified English. It's fetching the data. Then it's doing the transcription. Then you will have the prompts that went in. So this was the prompt that actually went in. This was the transcribed version of the audio message. then you get this is the summary you end up getting. So if you take a look at the final output, what you will see is here is the transcript, here is the summary, the sentiment, what was the intent of that particular call, and what was the topic related to that particular call, all of that extracted out. And now because it's an API output, you can say, oh, go back and update my system. We're more than happy to do that. Yes. I mean, we are starting to support Whisper as part of the stack. So, but you can use any other model if you want to, absolutely. Yes. So what you can do is you can create a GALE flow, and essentially if you have historical content of email agent conversation as a bunch of emails, you can push all of them as an input and run this several times to get a summary as a separate piece of output, and you can save them somewhere. Huh? Well, I mean, right now it won't. If you can configure to make that happen. Okay, one last flow I'll show you, and then we can wind this down. This one is one of my favorites. Also, it's interesting because I spent a significant amount of time in my career in claims, auto claims, as a consultant, and there was one of the things we used to see was they used to spend a good amount of time optimizing for straight-through processing. If a claim comes in, if the damage request is less than a certain threshold, they don't want to manually process that, because if you want to adjudicate a claim, then an individual has to go where the car is, evaluate if the damage is true, etc. That cost of that is probably higher than the amount of the claim. So they want to do straight-through processing for these. So once you understand that straight-through processing can be done, typically what they do is they used to do historically, there's one individual who's sitting and taking a look at the image that the customer sends and say, okay, this damage can be paid. And that's the best guesswork based on their experiences, right? So what we have done here is, first, there is an image that comes in. I'll show you what the image looks like. So, ideally you would send only the damaged image, and in the real flow you would go to the policy system to get the original image upon which the contract was written, but we're just sending both of them together. Now there is a vision model that does the analysis between X and Y and identifies what the potential damage could be. Once it identifies the damage, then it goes to the backend, and it is based on the parts it has figured out. It's trying to understand what the cost of each of those parts are. Once it figures that part cost, basically it's going to summarize all of that and then say, is it beyond the threshold you're asking me for? And then it gives a recommendation to the adjudicator saying, this could potentially be a straight-through processing or it may not be. And give some recommendation. It's not obviously doing that by itself. But for the adjudicator, then there is not only their experience comes into play by looking at the image and say, maybe this is beyond the limit or maybe not, but also there is a model that's supporting them through that process. And typically what we have seen is in the insurance, when I was seeing that, these evaluators are highly experienced. They've been in the industry for a long, long time, because if you go wrong, there's a lot of loss for the organization. But with this, you could probably enable moderately experienced folks to be able to do that analysis without having the ones who are been in the insurance industry forever. So it takes a few things as an input. Obviously, the damaged image, what's the threshold you're looking for straight-through processing, and then it also, what's the total IDV. So it's going now and doing the vision analysis of the model, extracting out pieces of information. I will actually show you what the output looks like. This is what it had generated previously. So the exact same image I had used. And it'll actually, it has identified which part of the car the damage was, the front bumper, left fender, blah, blah, blah. Then it has gone and we have a list of all of these pricings, obviously dummy pricings. It has extracted that piece of information and then it's giving a recommendation. And it is also saying that there may be some damages beyond that's not visible in the image, so that's something you may have to evaluate. But based on what we have seen, maybe it'll exceed the threshold that's been given. If I increase the threshold, it may be a different story. And this can get quite powerful, especially when you start combining this and the audio and the entire workflow of various different models to generate different kind of content out. And you'll be able to optimize significant amount of processes within your organization. I think with that, I will take any more questions you may have, probably for the next couple of minutes, and we can wind this down.
Thank you.